Okay, this is going to be hopefully a fairly short video that begins Unit 9 on chemical reactions. So here's my PowerPoint. Now, depending on what teacher you have, you might have a little bit different PowerPoint, so you could also look at theirs. But anyway, this unit gets into the actual chemical equations where you see the arrows and the plus signs and all of that, where you have something over here on the left, maybe plus something else, and then it's going to yield maybe some other things, okay? So anyway, chemical reaction. It's a process by which one or more substances are changed into different substances. So really what we have is we have the original substances, they react however they do, and then they actually form new substances with new properties, and that's very important that the new substance have different properties than the first, right? If they had the same, then why would it ever go through a chemical change? It wouldn't. So we call these chemical changes. If you remember back maybe a couple units ago, a chemical change, you might notice something like a color change or a smell or something like that that might indicate a chemical change has occurred. So here we go, the indicators. I just mentioned a couple. Bubbles, fizzing, fumes. Now make sure you would never actually put your nose over something, okay? But if you could see fumes come up or notice some sort of smell, that is an indication that we had a chemical reaction, that you do have new substances. This color change, you know, sometimes that could just indicate a physical change, like if you're dyeing wool or you colored a paper a different color, but that's not what we're talking about when we change color here. Okay, the change in color is a direct indication that you have new substances form. The texture of it looks different, maybe the taste, but we should never really resort to tasting anything to see if it tastes different than the first. Down here we have what is absorbed or what can be absorbed or released: light, heat, electricity, sound. You hear something, you see something, you notice that the temperature increases or the temperature decreases. Those are all signs that a chemical reaction occurred. And this is a big one right here. Precipitate. Insoluble means not able. Remember, in means not. So not soluble, solid. It won't dissolve in water. A lot of times our compounds, our original compounds, will be in water, okay? And then when they mix with whatever they're reacting with, you would get new compounds, and you might see like a white solid or some sort of colored solid form at the bottom that's not dissolvable in the water that it's already in. All right, we call those a precipitate. So that's a very important term there. Okay, it may settle to the bottom, it may float. Sometimes too with precipitates, it might just look like the solution went from clear to cloudy, and that would be an indication of a precipitate. Now, what do they actually look like? Now, my PowerPoint's fairly long, and we're going to cut this one short. But what does this look like? Okay? So, in the last unit, you were working on writing compounds, like, for example, magnesium, 2+, oxygen, 2-, do the crisscross, MgO. Okay? We would get a 2 and a 2, and we reduce down to this. So basically, we're doing that same thing for our original compounds, okay? So we'd have this compound reacting with another one and forming new ones. So you are going to use the chemical symbols. These are chemical symbols. We will use the chemical formulas, the compounds. The thing that's a little bit different in the actual chemical equation, or something, I shouldn't say different, but new, is there are going to be these coefficients, okay? So you may see in front of, like here it says H2. That'd be 2 hydrogens, diatomic molecule, and maybe you have like a 2 in front of it. So the way I look at that, 2 times 2 would be 4. I'm getting a little bit ahead, but these are coefficients that tell you how many of these you have. So for example, let's say you had H2O, and that's one water molecule. I think most people know that H2O is water. If I were to put a 2 in front of it, it just means we have 2 of them. So you have two little molecules of H2O floating around or whatever. I guess they're in water, so they are in water. But anyway, you get the idea that this tells you just how many of the molecules or how many of the compounds you have. Okay? So this might be the last one for now. How are equations written? Reactants, what it's reacting on the left, what is being produced on the right. Now this arrow that we have in the middle means yields or produces. Okay? Now most of the time I think most of the time when I read out the chemical equation, I will use the word yield, right? This compound plus this compound yields these compounds or this compound. But it's a term that we use, yields, meaning produces. And so like we have here reactants. Now, I've been also referring to reactants as always being like two. Well, there is a chance that it's only one. So you could have one or more substances that start, and then at the end you could have one or more substances that it produces, okay? And then further on in the unit, we'll go on to talk about what those are called. Okay. Check out the next one. Yep. And that was that for part one of the notes on chemical reactions. We'll get into actually writing some so that you could see in how they're written. You could even see one down here. This plus this yields these. Looks kind of crazy. Not as difficult, I don't believe, as it actually looks, though.